exponential function and sketching them. Oh, very good second. An exponent is what? A number in what position?
To the
What does it
power.
do? It's a power. So if we have, the basic idea here is we've done equations like this. This would be a line. We've done parabolas. What we're doing now is we are putting the x in the exponent.
Oh no.
Ooh, oh boy. They're actually not that, it's not that difficult based for what it is that you need to do. There are two types of these things. We'll go with the easier one first. Okay. Let's say we have y equals 2 to the x. And what you need to know, one thing that you'll need to know is, this is on the top of page 168, kind of, is that this type of exponential function basically looks like this. That's the basic shape. So your question is, or what you need to do is look at this and recognize what type of equation it is. It's an exponential because it's y equals something to the x power. And what I have, there's two versions of this. I'll cover the other one in just a second. So based on this, you say, okay, this is the basic shape, and then all I need you to do is I usually do 3 points for reference before I sketch in the shape. So what I recommend you do is do this. Whatever is in the exponent here, so the x variable, let's just pick some easy values, and usually -1, 0, and 1 are a great place to start, and see what it would come out to after that. So if in this equation here, if I plug in a -1 for the x, what's y?
1/2.
1/2. If I plug in a 0 for the x, what's y?
1.
If I plug in a 1 for the x,
2.
I get 2. 2 to
Oh,
the,
it's just
get my other hand figure, 2 to the -1 power, that's 1 over 2. 2 to the 0 power, anything to the 0 power is 1. And then 2 to the first power is 2. So based on this, get my axes here. Not very good. It's been nice when I have the TV going so I can actually just graph it for you. Okay, so knowing that this is the basic shape, let's get these points on here. When x is -1, y is 1/2, so there's a point here. X is 0, y is 1, x is 1, y is 2. So now I have 3 reference points. If you just look at that, and depending on how good your drawing is, you might think that's a straight line. But based on this, you know that it's not. It needs to be a curve like this. And just so you know, it never touches the x-axis down here, and it just keeps going forever that way, kind of that way. So when you draw this in, when it comes this way, it never touches the x-axis, but it goes on forever that way, and it goes up like this. And I have now sketched it. Oh, ta-da! Pretty difficult. Now, I do want you to be able to do, I noticed this didn't take me very long, because I was explaining it to you as I went. That probably took about twice as long as it needed to. You can also do this on your calculator. I want you to be able to do it both ways. On your calculator, your fancy schmancy TI 80-something graphing thing, the way you do that is in the way upper left corner, you have a button that says y equals. Press that one, and that will take you to a screen where it has a list of equations, y1, y2, etc. Typically you just use y1. If there's anything here, you can put your cursor to the right of the equal sign and hit the clear button. Then you type in your equation. In this case, you would type 2. Then you do to the power of, that's called a caret. There's a button for that on there. And then the x. The button you press to get this is the button toward the top of your calculator. It says x, comma, it says x, comma, t, comma, theta, comma, n. It's this button. It's the button that you use for your variable. vast majority of the time we will be using a variable x. So when you press this button, you'll get an x there. And again, thank you. It's a good idea to stop in. Let's see. Nope, where am I going? Zoom. There we go. It's a good idea to hit the zoom button. It's top middle, and go down to. I do like Z box, but what we're on now is a Z standard. So number 6 for Z standard. And what that does, that makes sure that your viewing window is at a good size that you can actually see things well. So you hit the Z standard, and see 1, 2 to the power. Where's your buttons right now? Power of it. 2 to the power of X. Enter zoom standard, and then you go to graph. Hit the graph button. And then your calculator shuts off, apparently. Your batteries are low.
Oh, I got you.
Dang.
Dang it.
Looks like you got a couple things in there.
Mine has a backup battery.
Hey, it's okay. Don't.
Mine had the backup.
Yeah, mine does.
Alright, so 2 to the X,
I need a battery.
zoom standard, and graph. And it'll draw something that should, what's on the calculator screen and your sketch should match. Can you focus well? Excellent. So,
Okay,
that's what we're looking for.
one battery.
like I said, I do want you to be able to do it both ways. I don't want a class full of students that just knows how to punch buttons on a machine. This is a $100 and something tool that I want you to be able to use also.
So when we have problems, it'll give us y equals 3 to the exponent of x, and then to the x power,
Mhm.
and then you plug it into your, well, either you do it out or handwritten, or you plug it in here, and
Yeah,
then write it.
do a quick table of values with 0, 1, and -1.
Okay.
And then
Mr. Good.
to get your 3 specific points, and then sketch it in based on this shape, and you can confirm it with your calculator.
Now,
Also
from what we
use-
learned yesterday, does that apply to this calculator also? Can we do that again? Like the
Oh, the reciprocal functions? Yes.
the equations 1 over x and...
Yes, the reciprocal functions, y equals 1 over x, 1 over x squared, 1 over x plus something, etc. Yes. I want you to be able to have a rough idea of how to do things by hand, but it is also a valuable skill to know how to do it in a calculator. Yeah.
Why do you always use -1, 0, and 1?
Because those are the easiest exponents to do.
Easiest.
Anything to the 0 power is 1.
Could you use
Anything
any
to
number?
the first power is itself.
Wait, I was confused.
Could
when
you use
got
any
it.
number?
Well, you could, but then you're going to get dots over here that are very close together. There's difficult to use this way, or they're going to be spread out way too much over
But
here.
it would look the same.
Well, it would, depending on how good your sketching is. Just trust me when I say that these are the
I just-
easiest ones to do.
Like if you didn't, would you always have to use a negative number in there? Because if you didn't use a negative number, you use positive numbers, that would be over on the positive
Well,
axis.
if this is a 2, sure, 2 squared. Let's say this was an 8, and it was 8 squared. It's kind of tough to graph that.
Yeah, but I mean, if you did, it would be on the right side, it wouldn't
Yeah,
work.
you would still get the basic shape.
Oh,
So,
Wait, I'm still confused on how you plugged in -1 and got a half. Because if it's 2 then -1, wouldn't that just be -2?
Eighth, move it down below.
Oh.
right, negative exponents, cross the fraction line to change the sign. Okay, so, what I didn't tell you earlier, I now have to tell you because we're going to learn the other kind also. This is the shape of y equals, what is the book called? Why don't you shut the door, please, to the hallway? And I'll just call it n, some number to the x power, but this is when n is greater than 1. It looks a little bit different if n is less than 1.
Orange.
Not the least of which because it's in a different color. For the same type of equation, when n is less than 1, and I should also specify above 0, with some fraction. It's the same basic shape, except it goes this way. So let's do an example like this. And we have y equals 0.25 to the x. Frankly, a lot of seems might seem counterintuitive to you, but sometimes it is easier to do it as a fraction. So let's say y equals 1/4 to the x. Same process. Let's do a quick table of values, x and y. And what's in the exponent? The exponent is the x, so that's where I want to plug in -1, 0, and 1. When x is 1, it's just the 1/4 again. Anything to the 0 power is 1. And what about if I plug in a -1 for x?
It would be 1/1/4.
Yep, it'd be 1/1/4, which is
4.
4. So, sketching this. And notice, since I know that in either case it never goes below the x-axis, I don't need to draw too much down here. When x is 1, y is 1/4, so about there. X is 0, y is 1. When x is -1, y is way up here at 4. Now I have 3 points, and so then I can sketch my graph. Remembering that it never touches or crosses the x-axis over here. And now I've done that. And again, you could also confirm this on the calculator by going in and typing, when you type it on the calculator, it's probably easier to do the decimal. So 0.25 to the power of x, and you should get the same window again. And that is how you sketch exponential